This one here I chose is a synthesis using alpha carbon chemistry. And usually when we say it's just to use synthesis using alpha carbon chemistry is usually a little bit of a lie, because you got to use other stuff too, okay? Because by now you know all sorts of reactions in organic chemistry. So alpha carbon chemistry means that that is as far as you can go, okay, with your reactions. So one of the neatest things about reactions using alpha carbons is that you form carbon-carbon bonds. When you form carbon-carbon bonds, you can form really large molecules. You can do cyclizations. It's really interesting stuff. Okay, and so this synthesis is not about making huge molecules, but we are going to make a molecule in which we are going to add some carbons and whatnot. Okay, so right now let's get started by looking at our starting material and the product, okay, that we have. So in the starting materials, we have a diester, and then we still have an acid group in our product, okay, but we have some methyl groups that we don't see here, okay, in the starting materials. So which means we need to add some of these carbons in there eventually, okay, at some point, and we need to get rid of the ester also. So the first thing we can do, if we have a diester and we have a ring, okay, that we are forming here, we can start with cyclization, okay, cyclization using Claisen, okay, reaction. So let's go ahead and erase all of this. So we start with a neat compound, and I'm going to write my reactions here on the side for us, okay, so that you can see all the process that we are following. So hopefully I will write it out as we go. All right, so the first Claisen reaction that we have to do is going to be using a base, okay, and when we use a base, you can use sodium hydroxide, LDA, whatever you want. I'm going to go through this a little bit differently because I'm not going to write the mechanism. Usually when we do synthesis, we don't write mechanism, we just write reagents, because it's understood that you know how it's going to work, okay, and how is it going to work? Well, this is the alpha carbon. This is going to be the beta carbon, or the beta keto. Okay, so which means this is the negative. That's going to be our positive. So 1, 2, 3, 4, 5, 6. Okay, that's my 6-membered ring that I'm forming over here. Okay, so let's do that. And here is the ring. And so 1, 2, 3, 4, 5, 6. Okay, on the first carbon, I have the ethyl ester. On the 6th one, I'm going to have a ketone. That's my beta keto ester. Okay, now if I look at the product that I have, on the beta carbon right here, this carbon is what is number 6, okay? On the 6th carbon, I actually don't have a ketone, I actually have a methyl group. So how do I get a methyl group from a ketone? It means that I have to do another carbon-carbon bond formation. Now this is using a ketone, okay? So now with using a ketone and forming a carbon bond, that can only be done by a Wittig reaction, okay? So we'll go ahead and do a Wittig reaction here, and I'm going to use PH3, P, and then of course the CH2, because we need only one carbon here. So this will then give me an alkene, and alkene is not what I need. What I really need is CH3, which means that now I need to do hydrogenation on it. And so my third step here is, well, hydrogenation. And so, and you don't need to write what I'm writing on the right hand side, you just need to write the synthesis. So COOET and then that, okay? So I have done this, but I also know that I actually have a methyl group here, okay? And the way to add a methyl group here next to an ester, okay, not an acid, but an ester, is going to be through another alpha carbon chemistry. Now, the alpha carbon is fine, but if I were to do that on this compound right here, I would have many alpha carbons. I would have at least 2 alpha carbons, okay, carbon number 1 and carbon number 5. So which means that if I chose to add this methyl group in this step, it's not going to work, because I'll have multiple products, and I don't want multiple products. So what I'm trying to do by doing the Wittig reaction first is I'm eliminating my alpha carbons, or how many alpha carbons I have. Okay, so that's the purpose of doing the Wittig first. Okay, so now what I can do is I can focus on adding this carbon now. Okay, so I have to add a methyl group. And the way you add a methyl group to a carbon next to the ester is through, again, alpha carbon chemistry, which means that here I'm going to go ahead and add LDA, which is a strong base, and then I'm going to go ahead and add one carbon. So this is just alpha carbon. Okay, so nothing much, alpha carbon alkylation. So that's what I'm going to do next, and that should give me my methyl group here, and I already have a methyl group here. The last thing that I need to do is get rid of the ester. Okay, and there's only one way to get rid of the ester, and that is by hydrolysis. Okay, so H3O plus, that will take care of the ester, and so now I will get my carboxylic acid. Okay, so this is the synthesis. Now I could have gone further, I could do other things also in this one, so but I limited here to carboxylic acid. I could have also added heat, and if we add heat we can totally get rid of the carboxylic group. So things like that. Okay, anything is possible, right? So when we start doing synthesis, anything is possible. So the last step was then hydrolysis. So this is a 5-step synthesis, as you can see, a little bit more than 5 considering that this is a 2-step thing, but still. Okay, so it's a 5-step process that we have to take in order to get the product that we want, and this used reactions from 3 different chapters. Okay, and this is kind of what happens when you get towards the end of organic. Okay, all right, I hope you enjoyed that synthesis. I did.